Okay guys, so we're gonna explain today how to send a transaction. So a little presentation. Okay, it doesn't work. Little presentation about myself.
Faut que je mette peut-être le truc ici, ouais. Vas-y là. Voilà.
So my nickname is Moore, my website. So I joined the Uniter project around 2014 and 15. I'm the Silkai author and developer, which is a command line client. And I'm recently a Uniter developer, which is a Python library for Uniter clients. So what are we going to talk today? A little bit about documents into a cryptocurrency, the source management into Uniter. We're going to study in detail the transaction document and how the signature works into a cryptocurrency. And then we're going to study a little bit about different practical cases around a transaction. So a little bit of glossary before. So we're going to use TX for transaction, UD for universal dividend, and WOT for web of trust. So yeah, in Uniter we have many documents. So in general, a cryptocurrency comes with two documents, a block document and a transaction. And Uniter implements 4 other documents. So for the web of trust, the certification, identity, membership, and revocation. So from a client perspective, what are the interesting documents? So this is a transaction, certification, identity, membership, and revocation. So before talking about the transaction, we have to understand how the sources are working into Uniter, how they are creating, how they are transferred from one key to another. So yeah, in a G1 currency, a block will be created every day with a field, a universal dividend. For instance, currently this is 107, which is currently in the block. And how the transaction is working, so we have inputs and outputs. That's how it's working. So we have to specify this. This is the way it works. So now I'm gonna retrieve the sources from a pub key with using cur, and here this is the host and the port, and the BMA API with transaction sources and one pub key. So I just pick one, and we're gonna explain in details all the fields. So the type of sources can either be a transactions or a universal dividend. So we will use D or T. And then we have 2 fields, which is here to identify where the sources is coming from. So in case of a universal dividend, the no offset will be the block number, and the identifier will be the block pub key of the creator. And in case of a transaction, so the no offset will be the position among the outputs, and the identifier the hash of the transaction. So then the amount and the base. So why do we have a base here? Yeah, this is decimal base. Why do we have it? So the idea is to, as we are creating a lot of money, the storage integers into the database will explode. So we have to handle a rotation. So that's what we handle here with the base, with a rotation of the amount. And then finally we have the conditions. This is the conditions to unlock the source, and we will come in details more later. So let's talk about the transaction documents. So here's one very simple one. So we have the version field, which is here for the evolution of the documents, the type, the transaction, certification, and the 3 other ones. The currency can either be G1 or G1 test. The block stamp, so this is the block number and the hash of the block in which the transaction have been added. So yeah, why do we append at the end the hash? In case of a fork, so two blocks will have the same block number, but the hash will be different. So that's why we are appending the hash at the end. And then the log time, this is used in case we want the transaction to enter later on, not directly just when the node received it. So yeah, if we put 48 hours, the transaction will enter later on. So no client is currently using it, but it's a nice feature which could be implemented. Then the issuers, so yeah, there could be many issuers, that's a nice feature too. So the inputs, here we just have one. How does it work? This? Oh, can you remove it? So here we have the inputs with the amount, the base, the type we saw, the identifier, and the an offset here. So then we have the unlocks. So this is the condition to unlock the inputs. So we have two of them. We'll come in later on detail about it. So we have the sig for signatures or XHX with a password. So here, and the 0 means for the first input. If we have 1, it will be a second input, etc., etc. And then we have the outputs, the output sources with still the amount, the base, and the condition.
This 0 is for this input, this 0 is for this issuer.
The 0 means here for the first input. If we have a second input, it would be 1 here, and sig 0. 0 means here just it has to be unlocked by the pub key of the recipient here.
The pub key of the recipient
of the issuer. No, of the recipient. The person who will receive the amount. Ah no, sorry. Yeah, I will explain more in detail how the lock and unlock about the sources is working. So yeah.
Okay.
Then a comment. This is here transaction reference for human. And at the end, it's happened the signatures. So yeah, there could be many signatures because there could be many issuers. So yeah, we'll come more in detail about this later. So yeah, there is many unlock output. So the first one, the most used into the clients right now, this is the sig, which means signature, and inside we specify a pub key. So if for this output we specify a pub key, so then the receiver will have to have this pub key in order to unlock this source. Then we have the CLTV, which is stand for check log time verify.
Can you go back please one?
This one? Previous?
Yes. Input. Where is the amount?
Of the output or the input? Here or here?
This is the amount.
Yeah, the amount.
But if what happens if the amount is because the amount is coming from another transaction?
Sorry.
In this case, the amount is this transaction is coming from another one.
Yeah.
So what happens if we want to transfer just part of it?
We'll come on. We'll come in detail about this later. Yes. I just want to make it simple now. There is too much information. Yeah, step by step. CLTV. So this condition you will put an absolute time, so a timestamp for instance, you want on 2025 you want to unlock this source, so you will put the timestamp in it, and the source will be unlocked when this time arrived. And this one is quite similar, CSV, which stands for check sequence verify. You'll put a relative time into it, and for instance, you can put 48 hours, and after the transaction enters the blockchain, this counter will start, and 48 hours it could be unlocked. And the last one, which is a bit more complex, XHX, what I found is stand for XH of password, something like this. And inside it, when you lock it into the output, you will put a hash into it. So it can allow many features, like allowing to unlock a source with a password, and to allow cross-currency transactions. And these 4 conditions can be compiled together with and, or, and parentheses and spaces. And it has a limit of 100 characters, otherwise it will explode. So now we'll answer your question, how the inputs and the outputs logs condition are working. So first we're gonna exclude the CLTV and CSV lock, which get unlocked automatically when the time passes. Then we still have 2 remaining ones, so the SIG and XHH output conditions. So they work in pairs, so you lock the sources with one and you unlock it on the other side. So for instance, with the SIG condition, if someone into the transaction one want to send these sources to someone else, he will put the pip key recipient into this condition, and then the recipient of this transaction, who wanted to use these sources, will have to use this one, SIG, to unlock it, and append at the end of the document, as I showed you, the signatures of his signatures to the document. Did you get it? Yeah, no? Okay. Then same for XHX. So this time it's a little bit more tricky. So first, on the client side, you define a password that you keep for yourself. You share it with hash it with SHA-2056, and then on the output condition you will put this hash into this condition. And the recipient, if he doesn't have the password, he won't be able to unlock this source. So you have to give him this password, otherwise you won't be able to unlock it. So we'll come later on detail about this, but this allows the cross-currencies transactions, which is a nice feature, but not implemented by any client today. Now we're going to talk about the signatures. Why do we have signatures into a cryptocurrency? What is this for? How do we ensure that someone is not using your sources, is not sending a transaction or certification with your account? So the way we found, here for instance we have a document. So for instance, transaction, we hash it, and this hash we will use our private key. So we enter our credentials, and we get signatures that we append at the end of the document here, and then we send it to the node, and the node will perform a verification on it. So he will he will perform a hash and decrypt it. He just take the signatures at the bottom, and then he decrypt it with the private key, which is into the database, not an issue, and we'll compare the hash of this function, and if it matches, then this is the good issuers, which is sending this document, otherwise it's not working. That's the way to identify that this is the good person, the good person which is sending the document, not someone else. Question?
It's a public key.
Yes.
Well, yeah, it's not with the private, but with the public key.
Yeah, just with the public key you can.
Yeah,
Yeah, this is the reversed part of this one. Yeah. Is it? Did you understand it?
Yes.
So now we're going to study a little bit of practical cases into, from a client point of view. So with my experience into Silkai. So now imagine you have a big source and you have 100 units and you want to send just 10. What can you do? So what you're going to do, you're going to send 10 to the person you want to send, and you will send the rest to yourself. So this is the previous transaction, which I just removed some parts. And here we have two sources. Again the unlocks. And then we send this one to the recipient who want to send it, and this one to ourselves, which is here, the issuers. So we retrieve back not the whole source. Yeah, that's very common. Now, what if we want to send a very big amount? If we don't, first of all, you have to know that Juniper has a limit of 40 inputs into the transaction documents. So what if you need 50 inputs to send this big amount here? What will you do? So the clients are implementing what we call the intermediary transactions. So before sending the final transaction with this amount, we'll perform like a combination of all the sources. We will put all these sources. We will take 40 sources and retrieve just one sources. We send it to ourselves and then we combine it. That's the way it works. The program could chain many intermediaries transactions. It already happens to me with Silkai, or I think Cesium also implemented quite well. Now, what if you want to send a single transaction with many recipients? So this is, we already have two clients which is using these features, so Silkai and Remuniter. So to remunerate the block issuers and the Juniper contributor, and for instance we are using Silkai to remunerate all these Juniper's developers. So here's my pub key, for instance, and this is the all transaction block, and in the output we specify all the pub keys, and you can see at the end. So this is the issuers, the Juniper pub key of the project.
Is there a limit on the output?
Good question. I don't know. Now, what if we want to send a transaction with unlockable sources at a certain time? Do you remember what we said earlier? No? Can use CSV. You put a time into it. For instance, time now plus 48 hours. Then it could be unlocked. If we put the CLTV with a timestamp, 48 hours to again unlock. No client are using these two features right now. Now this one, which is quite interesting, so the locking with XHX. So more details. So the transaction one, we use the password RML13. We hash it, and into the output condition we will put this one, the hash. And the guy who will receive this transaction, we have to know the password, and into the output unlock he will have to use this one, otherwise he wouldn't be able to receive this source. And yeah, from a node perspective, you will have to check this. Quite easy. Yeah. What if we want to set a transaction from several issuers? So yeah, no clients are currently implementing it. So let's imagine we own 2 pub keys, and we don't have enough money on one or the other one, and we want to use both together, and we're gonna use both of them, put all our our inputs into the document, as well as 2 signatures at the end, and it could work. But yeah, no clients are using this feature right now. Now let's come to the interesting fact, which is quite tricky. The cross-currencies exchanges. So let's use a lock time 48 hours. The transaction won't enter into the blockchain. So that way, the guy on the other currencies will know that this transaction exists, but it's not applicable right now. So now we're going to use very big conditions, quite tricky. So we put the signatures of the recipient that you know, and the other condition will be that the recipient will receive the password. We will give him the password just if we receive the units from the other currency. If we don't, we won't give him the password. He won't be able to unlock the source. And in the case he doesn't send the money on the other currency, you have a way, your source will be locked, and you can have a way to unlock your source. So you are the issuers, you can unlock this one, and if you wait for 48 hours, you will be able to retrieve your sources that way. Yeah. So yeah, it's quite tricky. If you want to learn more, there is an article on our blogs on junitea.org. I will show you the link at the end. You can read this in French, in English. So, question?
To well understand this, have the other part in the other currency could help the password exchange to...
Yeah, I think the password should be exchanged, not from the currency itself, but by giving from a normal messaging means.
But
what do you mean?
Here you have the unlock property and the back. The give back.
To retrieve your.
If nothing
happens here,
Yes, but why it's useful in this case? Because we have the same in the other currency to make the change.
Yeah, I think on the other currency we should do the same. Yeah.
To well understand, for me it's missing like in the a graphic with this, then this, like Eloise
it is on the blog.
Yeah,
it is on the blog.
Okay.
Yeah, there is a blog article very well explained. Yeah, Hinso wrote it before. So yeah. So yeah, now we finished with all of this. I just released Silkai, the last version, so just one slide talking about the new features, nothing more. So yeah, there was a big part working on migrating to Junitea Pi. Previously it was using some internal code. Now we are using something more robust, and also sharing code with Sakya and other future Python clients. And we also migrate, we migrate to Click, which is a command line interface, a much better one, because previous one was a little bit buggy, and this one is into Debian. That's the reason why we migrate to this one. Now we can display the transaction history. you put Silkai history transaction, you will get your full list of transactions. A very awaited feature. Then now we have a package into Debian and Ubuntu. That's a very nice feature. Yeah. So
is it thanks to Jonas?
Yeah, thanks to Jonas.
Because we have a contributor in June, Jonas.
Living in Denmark, yeah.
Single Moon ou je sais pas quoi. With maintaining something like 10,000 packages, Debian packages, and he's a member of June.
So yeah, a little bit of link if you want to join us, the technical forum, XMPP and Matrix chat rooms, and yeah, HowForge using GitLab. And yeah, if you want to dig deeper, so there is one example into JuniterPy to send transaction. So this is Python, but yeah, it's a basic transaction, but you will understand how it works, and you can send with this a transaction. Then the Juniter protocol with all the rules, everything is inside, but quite tricky, complicated, but it was the case to have a look. And then the previous article that I talked to you about the cross-currency transactions, yeah, also in French, you just change here to FR and it should work. So yeah, I published these slides under the GNU GPL v3. You can find the sources here, and here the slide, yeah, from a website, from your website. And I created this with Remark, which is a nice slideshow. And yeah, if you appreciate my presentation, you can give me some coins here. And yeah, thanks. And if you have any questions.
Les TX, si j'ai bien compris, proviennent des index. Quand tu fais une requête de TX sur des TX.
Des index? Qu'est-ce que tu veux dire?
Dont on parlait tout à l'heure.
Ouais, mais moi je travaille que d'un point de vue API BMA, du coup j'ai pas d'index, je récupère l'historique.
Ouais, tu bénéficies pas des index. Les index dont on parlait tout à l'heure ne bénéficient que à Juniter lui-même.
Ah si, l'indexation des transactions dans Juniter, c'est utilisé pour récupérer l'historique des transactions.
Ouais. Et toi tu vois pas, toi tu parles de BMA.
Que BMA.
Okay.
En tout cas, il m'a fait le coup sur une grosse transaction. Hein. Il y avait un bug là.
Ouais.
Il y avait la moitié qui c'est ça. Qu'est-ce qui s'était passé? La moitié qui était revenue, c'est ça?
Ouais, je sais plus.
C'était perdu, moi. Sur une version ancienne. Hein.
Ouais. Tu as des exemples d'applications sur le récipient, c'est multiplication?
D'accord.
D'avoir plusieurs issueurs, plusieurs récipients. C'est pas implémenté, mais.
Bah, c'est pas implémenté, mais je sais pas, on pourrait générer à la main ce document, c'est pas très dur.
Il y a des applications qu'on fait à faire ça?
Oui.
Plusieurs choses, ouais.
Tu crées un compte d'une association, par exemple. Ouais. Et il y a 3 gérants. Il y a 3 gérants.
Ah, et 3 gérants.
Cette somme-là ne sortira pas si les 3 gérants n'ont pas apposé leur signature et leur accord. D'accord? Donc tu mets cette somme sur un compte. Ce compte, quand tu déposes cette somme, les 3 signent dans le client. D'accord? Elle ne pourra ressortir que quand les 3 signeront.
D'accord.
Bon, il faut un client qui organise ça.
Bien sûr.
Ne signe pas à l'ancienne. Signaler, ça va être 3TX.
Comment?
Tu as dit les 3 signes. Ils signent que pour dépenser la monnaie, pas pour la recevoir. Oui. Pour la recevoir, ils n'ont pas besoin de signer.
Pour la recevoir, tu n'as pas besoin, puisque tu donnes les clés. Tu peux aussi envoyer. Il faut la condition, c'est que c'est 3.
Oui. T'as pas vu ça?
Oui,
ça existe déjà.
Quand tu reçois, mais on peut recevoir 3. Ça arrive sur ton compte.
Ouais, il y a Rémunitaire qui fait ça tous les jours.
C'est à l'émission, c'est quand tu vas les envoyer.
C'est qui rémunère ceux qui calculent les blocs.
Je peux envoyer des junes à ce compte.
Je vais arrêter le direct parce que sinon
je peux envoyer des junes à la condition
j'arrête le direct.
Clé de vite et clé de bout. J'ai pas besoin